Hello, and welcome to Connection of the Month, the series where we take you inside the HSS Connections Hub. I'm Ted Goldstein, structural engineer with Atlas Tube, and this month we're going to do things a little differently. Over the course of this series, we've taken a look at a lot of different calculators for a wide and growing array of HSS connections. But while we're continuing to add new calculators, we're also constantly updating them to make them easier to use and incorporate new features. So with that in mind, this month we're going to look back at the Wide Flange Beam to HSS column WT moment connection. This is a calculator that we saw a few months back, and since then we've added a range of features that are going to make it that much more useful, make it cover that many more different situations, and do it in an even more user-friendly manner. So with that, let's jump right in. So here I've gone ahead and set up a WT moment connection. And right away we can see, I've entered some loads and we've got a governing utilization of 194%. So we have some issues that we need to solve to get this connection to work. But before we look at how we're going to do that, I want to show you some general features that we've added to a lot of the calculators. So first of all, if we scroll down, we can see here on the right, we now have a top-down view. That's going to help us to understand the geometry of this connection and actually several other connection types where we've gone ahead and added that. Additionally, you'll also notice that we now have weld symbols. Now, these drawings are not going to end up on a set of contract drawings. They're there for the engineer, but in a lot of connections, there may be a lot of different welds that we have to keep track of. And by adding the symbols, we make it easier to understand which input corresponds to which physical location on the connection. The last thing I want to highlight before we jump in is that in an effort to make sure there are no black boxes and that everything is clear, we've added some new functionality to the dropdowns. So as it's always been, you can go ahead and hit any line of the calculation, and we're going to have an explanation, graphics when required, and then we're going to have the formulas and references where that's relevant. What we've added is now you can go ahead and click on any of these formulas, and it's going to give you some more detailed information. So in this case, we've got an inequality that we're checking. It's going to give us what the actual values for that inequality are and let us know which of the possible outcomes is active. And of course, we can click on the other ones as well and see that it is inactive. So there are cases where you may be trying to understand what's going on in the background with the calculator, and this is going to help us understand what's happening. So with those out of the way, let's talk a little bit about this connection specifically. We've got an issue here. Clearly, we're way overstressed, and the reason really comes back to some issues with the geometry of WT shapes. So in this case, we've got, if we go to the loads, you can see I've just put it all in dead load for simplicity because this is a demonstration. Of course, normally you could put in either the factored load directly or you could put in all of the load cases. But basically, we've got some axial load. That's a new feature as well. We've got some shear load, of course, and then we have the moment in the connection. So what we're finding is that the shear, we're at about 93% for that. That's that value there. Here we go, 93 for the bolt capacity in the shear plate. And then we've got a few different limit states for the moment that are way over 100%. The issue that we're running into with the WTs is that the shear plate takes up a certain amount of depth of the beam framing in, and we need to stay clear of that with the flanges of the WTs. But right now, we also need some more bolts to be able to handle this moment. And because these WTs are cut from wide flange, if we find a size that's long enough to accommodate more bolts, it's also going to have a wider flange, and that's going to interfere with the shear plate. So just to give an example, as with any place where you can select a member selection, we can go here to the WT section. We can hit select. And we can get a list of all the WTs, and on the right we'll see, does it work? Does it satisfy all the limitations? And then if it does, what is the percentage? So we can see as we scroll through here, really there's nothing that works. There are going to be a few sizes. We can see here these WT 10.5s that satisfy dimensional requirements, but they're still way overstressed. And we would continue to see that if we were to scroll all the way down. So fortunately, what we've gone ahead and added to this connection is the opportunity to use a built-up T. So if we go here and we go to built-up T, now we have, instead of a rolled WT, we have a T shape for that flange connection that's going to be built up out of plate, and that means we can completely customize the dimensions to suit what we're doing. Now, in this case, we're still up around 193% because I haven't changed the bolts, but because we have that freedom, I can now come up here and we have here the built-up T stem width. Essentially, that is the length of the flange plate portion. So we're going to go ahead. I think we're going to want to add a few more rows of bolts. So let's go from 7 inches to 13 inches. And then we're also going to go from 4 bolts in the flange to 8. So by doing that, right away, we're down to 130%. And actually, if we look in more detail, we're going to see that what is governing has changed. So by changing the number of bolts, we've now got all the bolt limit states down under 100%, with the slip resistance of the bolt group at 96. But we've still got a few other limit states that we're not yet satisfying. One of them is the moment capacity of the WT itself. So as with all lines of the calculators and the Connections Hub, we can come in here, see 130% local bending in the WT flange. If we're not sure what that means, we go down, go ahead and drop it down, and it's going to give us an explanation. So basically, right now, the flange of the WT, which has to distribute the load from the flange of the beam over the edges of the column, simply just isn't thick enough to do that. But that's a pretty easy fix. And again, because this is now a built-up WT, it's easy enough for us to come up here and just increase the thickness of that flange. So instead of using a 1/2 inch plate, we'll use a 3/4 inch plate. And now we've gone from 130 to 104. So let's take a look at what that last limit state is. Close that previous one and go now to the weld capacity. So 104%. This is a limit state that actually the rolled WT was working for because it had a wider flange. But in our case, if we look at the what this is actually checking, it's checking the weld between the WT and the column itself. And so right now, there simply isn't enough weld there. But again, very easy to change. Now, this is a flare bevel weld, so there's a limit to how much throat you can get from the weld itself. But fortunately, you can see we still have some space here between the flange of the WT and the shear plate. So we can actually just go ahead and increase the width of the flange. So we'll go from 4 inches to 5 inches. And when we do that, you can see now we've got an adequate length of weld here to transmit the load from the flange of the beam into the side walls of the column. And indeed, we've got our governing percent down to 96. So this, I hope, is a good example of the work that we're doing to always be improving the calculators on the HSS Connections Hub. Again, both in terms of specific features, for example, adding the built-up T, and in terms of the overall user experience, adding new diagrams, adding functionality when it comes to clarifying what's happening in each line of the connection. So with that, I hope you've enjoyed this month's connection, and I hope to see you next month.